So once again, we've got a kernel, and we know it's a kernel because it's been tagged with global. So it's going to run on the GPU, but can be called from the host. And once again, we're going to pass in a local variable, a parameter called array. And the trick is that this parameter is a pointer. And so this is actually pointing to some global memory that we've allocated elsewhere. And I'll show you how to do that in a moment. Once you've got a pointer to global memory, you can manipulate it, or you can manipulate the contents of that memory just as you would manipulate any other chunk of memory. So in this case, I'm going to take my array and I'm going to set one of its elements, which happens to be equal to the index of this thread, to some number, which happens to be 2.0 times the index to this thread. Again, not a very useful function, but it illustrates what's happening. So the point really is that since all the parameters to a function are local variables, or private to that thread, if you want to manipulate global memory, you're going to have to pass in a pointer to that memory. And of course, that means you're going to have to allocate a pointer. So let's look at how that works. Here's the code to show off how we use global memory. The first thing I'm going to do is declare some host memory. Okay, and once again, I'm using the convention that starting a variable with a prefix h underscore indicates that this is memory that lives on the host. So here's an array of 128 floats, and I'm also going to declare a pointer that I'm going to use to point to the global memory that I allocate on the device. And once again, the d underscore convention indicates that this variable lives on the device. Now, I want to allocate some global memory on the device, so I'm going to use the function CUDA-malloc. What's happening here is that I'm passing in a pointer to this variable, which is itself a pointer, right? And the CUDA-malloc is going to allocate some memory, in this case, room for 128 floats, and stuff a pointer to that memory into the pointer D-array. If you're allocating memory, you'll probably initialize it to something. So we use CUDA memcopy for that operation. And in this case, we pass in a pointer to the destination memory, which is this D-array that we've allocated, and a pointer to the source memory, which is this H-array variable, and then the number of bytes to allocate. And then we indicate whether we're copying from the host to device or vice versa. Oops, this is a bug. So now we've got a chunk of global memory, we've put something in it, and now we're ready to launch the kernel that's going to operate on that global memory. So here's the kernel that we saw earlier. Again, we're going to launch a single thread block consisting of 128 threads. I'm going to pass in this pointer where I've allocated and initialized some memory. So after this runs, presumably this code will do something to that memory that I pass in, and now I'll need to copy it back onto the host. If I want to use the results of this kernel back on the host, then I need to copy the memory back into host memory. And so here's that operation. Once again, CUDA memcopy. This time the destination is H-array, the source is D-array, the same number of bytes, and now we're copying from device to host. Okay, so that's how you use global memory. All right, the trick is that since you can only pass in local variables to a kernel, you have to allocate and initialize global memory outside the kernel and then pass in a pointer. Finally, let's look at how you would use shared memory.